Hi everyone. I'm going to be going over what we're covering for the Model View Controller lab. And it might seem a little intimidating at first, maybe it's very intimidating, but I want to make sure that you get exposure to how Model View controllers work, not just refactoring the code, but thinking about how you would look at your code. And I wanted to have a little bit of flexibility in the approach that you take. So the plan of attack, at least as I see it, I'm hoping that you will design a brand new version of or brand new shape class. So that could be anything that you want. It could be a rhombus, it could be a line, it could be what I'm going to show you, which is an animating shape. It's just going to be a rectangle that just moves, animates. And the various steps you need to take in order to modify it. Those steps are going to be very similar to what you do for the Model View Controller refactoring. I'm hoping the assignment's actually easier, but of course it's a little intimidating moving around a whole lot of code at once. So let's have a quick look at what we're looking at here. So if I just run the code, I've shown you this a bunch of different times, a bunch of different ways. Okay, if I draw a rectangle, it's not working as it should. This is what we've discussed, but I have implemented the triangle thing correctly, so it's acting as it should. So when I hover over a triangle, and notice I have an intersection point here. When I hover over the triangle, I get a selection event that occurs, and I color in the triangle. This is all broken down into the view, how I draw things, the model, what's stored, and the controller, how I handle mouse events. So when a mouse event comes in, and I realize that I'm intersecting the triangle, I set the state of the model. The model just sets the state. It doesn't care what happens with it other than that. And then the view, the thing that is calling paint, all it does is it checks the model. Every time it goes to paint, it just checks the model and says, hey, has anything changed? Or, hey, what color should I be? Actually is what it does. Am I selected? And if it is selected, then it will draw yellow. If it is not selected or hovered over, then it will draw white. So I've separated my concerns between how the mouse does things, what is being stored, and how it looks. I'm going to do that one more time. In my particular case, let me see if I can just stop this. Let's close it up properly. I'm going to make, I should have it in here, and if I don't, I might have to restart my video. So I have a framework, Model View Controller, Shape Factory. This might be the wrong file. This is the starter file. Hold on a second. I'm going to just load up the completed file, because that's not what I wanted to show you. Project. Okay, that's the starter file. You can put whatever you want in there. Here's my solution profile, Model View Controller, my solution. Here's what we should see. I know that we're not going to see that, but that's just because of the references and stuff like that are wrong. Here is an animating rectangle. The animating rectangle class is just going to extend the rectangle class. So it is a child class of a child class. So it's a grandchild class of these shapes. It has a constructor that takes in a bunch of different stuff, like the client, the size of the client rectangle. Essentially, that thing, by the way, is the canvas that you're drawing on, right? If your rectangle is bigger than that, you got to clip it. The background color that you're using, the x1, y1, x2, y2, essentially was defining the 2 points that will define a rectangular region. We can update our animation. Every time I have a clock event happening, I can say, hey, by the way, update what step of the animation you're in. That is brand new for the labs. You don't have to worry about that for the assignments, but I put it in there anyways. We can have timer events. So when this clock is going off at a certain basis, it goes off every 30 milliseconds or something like that. The clock is firing off at a certain rate or a certain time. And every time one of those things happens, I handle it in my controller. So I have, that's my shape view. Here we go. My controller handles one more thing than it did before. It handles an update time event. That's also given to you in the starter code, by the way. So every time the an update time event occurs, I get the current time. It is the number of milliseconds since the start of the program. And I'll get a message. I'm going to ignore that message. It's going to return true if and only if something has changed. So if the animation has changed at all, I want to set it to true, as in repaint everything. The animation should change. And beyond that, so this is just handling an update event. I also handle mouse events using the controller class. This just handles one additional thing. In fact, we can actually look at where's the controller event, the shape class here. And just in case I'm doing something wrong, update time, it's a virtual thing. So what I probably should have is, it's virtual as in, depending on which controller I call this on, it's going to do something different. So I just have a bunch of controllers. I tell all of them to update their time. For the most times, if I look at shape2400.cbp and go down to my and notice I also, in case you didn't notice, I put 3 different classes in the one file. The reason I did this, technically I'm allowed to do this. The reason you do this is they're supposed to be sort of a 3-in-1, like a trifecta, like a holy trinity, right? Your model of your view and your controller are considered one thing, even though they're not. They're 3 classes, but like Voltron, you just pretend that they're one. And so let's go to my controller. Here's my view class, all the function definitions for that. Here's the old paint outline. Let me see, update time. All it does is return false. So the default is just ignore the time. Ignore these clock events, who cares? Only when I get to like an animating object do I need to worry about the time. The timer goes off and you say, okay, I'm going to update my animation. Okay, so I have a timer event that goes off, it updates my animation. The animation would then change what position in the animation I'm in, and then when I go to paint it, I'm going to change what image I show or what I'm looking at. So as the animation goes, I'm going to keep around what percentage of the way through my animation I am, and then I'm going to change the size of my bounding rectangle depending on what stage of the animation I'm in. Okay, let's pretend, my animating rectangle, I have a new function called update animation. So it takes in the current clock time and it just changes what stage of the animation I'm in. It goes between 0 and 100 in terms of my animation percentage, and then loops around back down to 0. So at any given time, it's going to be between 0 and 1. The animation position is going to be, the animation scale factor, if you will, is going to be between 0 and 1. I also have to keep around the full animation time. I don't even know how much that's the time it takes to do a full cycle through the animation. So in my case, I'm going to set it to 2 seconds or 2,000 milliseconds. Right? That's how long it takes for me to do a full animation cycle. This is the current time, animation time. This is the start time, since the very first time I make one of these shapes. And so by taking the current time and the start time, I can see how many full loop cycles I've done and what stage I am in the animation. Okay, and then I can get the animation percent. That's going to be extremely useful for, so the controller sets this, the view gets this, the model keeps track of everything. The data is stored in the model, the view gets what percentage of the animation I'm in, and the controller updates the clock. All this thing is going to do, I can update the time. That's really doing nothing at all. It just updates the time. And then my paint method is going to be different. Let's have a quick look at my paint method and we'll see it in action. But you don't have to do an animation. You could have done a parallelogram. You could have, like a triangle, you'd make a polygon. You could try and do a line or an arrow or whatever you want. Just play around with it. You can just, if you want to keep it simple, copy what we did with, let's say, triangle, add another point, or change the background color. So have everything you have in Triangle 2400, extend Triangle 2400, and just change a couple little variables or change a couple little points. Make it, instead of a triangle like this, flip it upside down so that it works the other way. Whatever works for you. You just want something to show that you understand what's going on with it, with these shapes. Okay, so here is me. I set my things to safe values. I get my start time for the clock. This is telling me how many milliseconds have passed since the start of the application. My destructor is doing nothing at all because I didn't call new anywhere in here. I could have actually left it off altogether. Left on to show it doesn't do anything. Yeah. Something like that. Okay. Beyond that, here's me updating my animation. I just set the current time, and then I figure out how many the milliseconds of time in my animation that I'm in. So I figure out the start to end time, when I began my animations, all my animations since I made this object, the current time, figure out that difference, and then I mod it by the full animation time, which is how many times I've cycled through that animation. I don't really care about that number. I just want what phase of my animation I'm in. So I gave an example in the instructions for this tutorial. So if it cycles through every 2 seconds and I'm at 9 seconds, let's say, it means I've done 4 full cycles. 2 times 4 is 8, and then I'm halfway through my animation. In my case, I'm going to make it so that the rectangle is not visible. It's going to shrink down to nothing and then go back out again. And so my animation scale, where I am in the animation, it's the amount of milliseconds that have passed divided by the total animation time. That's the essentially percentage of my animation that I'm done. And so that's all it does. I just make sure it's in a safe value. I return the animation scale. Update time is not really doing a whole lot of anything. It is, so my animation controller, I get my update time, I get the model, I get the previous animation percentage, I update the time, I get the new animation percentage, and what I'm trying to do here is, in this particular case, I'm just checking to see if the animation has changed by a significant amount. If it's changed by more than 0.01%, then say I got to repaint everything. This is just arbitrary. 1% of my animation has changed, therefore I would expect to redraw things. Otherwise, don't redraw anything. The clock times are too close together, like 2 milliseconds have passed, no need to repaint it. Okay, and here's my paint method. I'm doing the exact same thing I did with rectangle before. It looks identical to rectangle, except right about, or should look identical to rectangle, except when we get to right around here. So I get the bound for the rectangle, and then I figure out what the animation percentage I'm on, and I see what I wanted to do is to shrink down and then go back out again. In fact, my animation is reversed from what I would expect. I could just flip it around. What I really want is, if my animation percentage is over 0.5, so over 50% of the animation, I'm going to take my animation percentage minus 0.5. So I'm essentially reversing the direction of this animation. If it's past the halfway point, it starts growing back out again, and if it's less than halfway, it starts shrinking down. That's what I'm aiming for, at least. So at 0%, it's, let me see here. If it's over 50%, yeah, I might want to play around with this. I might want to leave this alone as animation percent, and then do this one as, let me see here. Is that going to work? Well, we'll look at it. We can debug our own code afterwards. This does work, I know, but it looked backwards when I was looking at it. Okay, I figure out what the animation, the total width of the animation is, the total height of the animation of the bounding box itself, and then I say, well, I'm going to change this, and so I'm going to adjust where my left position is. I'm going to adjust where my right position is to shrink them closer together. I'm going to shrink those closer together as well, depending on where the animation percentage. So at most, you would expect the animation percentage, it'll go from, if it's under 50%, so what I wanted the animation percentage to be is, this is the total width in total. So at 0 amount of change, I have a full-size box, and at 50% change, I have 0 because it shrinks down to the center. This is just the math. You can play around the math any way you want. The big point is I'm going to do my filled rectangle. Instead of using the bounding box, I'm going to use a revised bounding box, and that's it. Everything else is the same. So I just figure out where my new animated rectangle is compared to the original bounding box of my rectangle. Okay, all of that code should work. The one thing that does not work yet, or actually it might be working, but I want to look at it again. I have a shape factory, and that thing there, it allows me to say, here are the different kinds of shapes I can make. I can make a circle, I can make a rectangle, triangle, and now this new animated rect. If I make an arrow, I need to put a new value in there. I just want some way of giving a number to these different shapes. The shapefactory.cpp, however, I set in the flags. This is from a mouse event. So if the shift key is down while I'm drawing out things, I'm going to make a circle. If the control key is down, I'll make a triangle. Actually, let's do that one. Let's do this. If flags and MK shift and flags and MK control. So if I have both this would be if I have both the shift and the control key down, I want to make an animating rectangle. You can do whatever you want with this sort of thing. I'm going to put this in here. I'm going to save this for the solution file that you get later. All right. So if I have both control and the shift key down, so the control key is down and the shift key is down, the control key is down and the shift key is down, then I'm going to make an animating rectangle. That's all I need to know. And so when I say make a model and the kind of thing I'll check to see what kind of shape I'm going to be making. So if control and shift are down, I'm making an animating rectangle. I'm going to turn these back on. I'm going to make an animating rectangle with the same parameters as everything else. So depending on how my mouse is pressed, I do different things. I'm also going to have to make different views. And so again, I'm going to make an animating rectangle, animating rectangle view. You'll be changing that for when you refactor your model view controller. And then here I am, I'm going to make a different controller. And this is the one time I actually need to make a different controller because I have to worry about animation. So depending on the type, I will get a different kind of animation. That's going to take some time. Why? Because I changed the header file, in case you're wondering. All right, let's see this in action. All right, does nothing. Triangle, still works. Great. Control Shift, draw, and I have an animating thing. Oh wait, I can even do the hover over thing, right? It's still detecting when I have a mouse event. I notice I just said if it's in the bounding box counted. I'm not going to try and trace down where this rectangle is, where it's animating. Heck, I could have the model say the size of the animating rectangle is if I wanted to, rather than calculating it during the paint method. That would have been perfectly fine. It's all up to you on how you want to approach this. But notice the animation is different than the mouse event. The actual animation itself is being determined by a series of timer events going off that you can hook into. And the model itself keeps track of what percentage of the animation you're on. Okay, and we can draw another one, and draw another one. And let's draw this one like this. I got a bunch of animating rectangles, all independent of each other because they're all getting a mouse timer event. They will, no matter what size it is, it will take 2 seconds to go in and out. And if I change that, let's change it. Let's have some fun. I'm going to go to my animating rectangle. Let's throw this in here. And I probably shouldn't have used a hard-coded value, so instead of 2 seconds, I'm going to make 8 milliseconds. Let's hope. I've never tried this. I'm improvising things here. Okay. Yeah, not exactly smooth animation. Why? Because the timer events are not actually setting things off. Actually, we're not getting a repaint event at all. The mouse move event is actually what's starting all of this. It's giving you a smooth animation otherwise. And if I don't do it, okay, we got a problem. We got a bug in our code. Great. We have an issue with, I didn't know about this bug. Okay, update time. That's what's going to be our problem. Because update time, I want to see if update time is actually, I'm getting the absolute value of start, n minus the start percentage, n percentage start percentage. Let's have a look at this. All right, n percentage is this, start percentage is this. Maybe it needs to be even smaller than that, because the amount of difference between the old percentage and the new percentage is going to be, oh yeah, I think that might be our problem. If these clock cycles are too close together, let's say 0.001, I want to have it go off most of the time, just not, for minuscule amounts. But if the clock cycle is too close together, those amounts are going to be so minuscule that you're not actually going to see anything. What I actually want, let me do it this way. Okay. Maybe I shouldn't have even done that particular approach. Let's have a look at this. So the mouse is not moving and it's animating now. Why? Because before, the amount of percentage difference that you're getting the animation wasn't sufficiently large to have it go off, because I've spread it out over 8 seconds. What I could have done instead of all of this is just say return true no matter what. So no matter what time I get a mouse event, I will automatically redraw everything again. That would have been perfectly acceptable. So we can try that as well. That's an interesting thing that we just discovered. All right, so I'm going to return true. And I'm going to get rid of this percentage absolute, percentage end. I can just get rid of all that part. I just want to update everything and just say true. It will redraw everything, no matter what. If I have one of these things, it's going to redraw every single time one of these clock events happens. Oh, that's the wrong one. Not moving my mouse, and it's animating. It's a slow animation because I said it was every 8 seconds. I can make it every 16 seconds. It'd be ridiculously slow. Or I can make it 1 second and it'd be extremely fast. So let's do that one last thing and then I'll stop the video. But the point is that you can play around with this. I think I even have a line in here as well in the solution file. So I can draw lines. I can draw arrow shapes. I can draw, do I have the arrow head in there? I don't think I have that anymore. But I've made a bunch of these different objects over the years. Just because it's sort of interesting to play around with this and see what happens. There you go. You can make it so it flashes different colors in the background every second and have it animate through different colors, between two colors. You might have a seizure, but you could do it, right? You could have it so that you have a line that spins around, or like that would be hard to do, but you could do it. the idea is that you can play around with these shapes so that when you draw something, you sort of internalize that we have this separation between how it gets painted, what gets stored, and how events occur. That's what we're trying to drive home. And this is just one other example of it. When you do the refactoring, it's going to be sort of driving home that point as well. So the controller and the view need to know about the model. That's one of the big points. Okay, so I'm hoping that helps clarify things somewhat. Have fun with this, right? Maybe don't bite off more than you can chew, but start with something relatively small and make a shape that you can make, and you can see how all of this stuff fits together. You're not expected to understand, especially for the assignment, you're not expected to understand all of the various classes. You're expected to take one of these things like Circle 2400 and be able to modify it, not know what every single line of code means. You sort of have to like relax your eyes and reason about your code that way versus trying to worry about how everything interconnects, because it'll drive you mad. This is a larger chunk of code, but hopefully it makes some sense of how all of these pieces are working together. Okay, thank you very much, everyone, and I'll hopefully talk to you soon.